Okay, so this is on page 9 of booklet 5. So this example says, given that the empirical formula is CH, and its molar mass is 26 grams per mole, you need to find the molecular formula. Now, remembering that the molecular formula is sometimes just a multiple of the empirical formula. They can be exactly the same as well, but sometimes it's a multiple of the empirical formula. So the molar mass is actually always for the molecular formula. So the molar mass you're given is 26 grams per mole. That's a molar mass. That's for the molecular formula. That would be the molar mass. So that's the molar mass of the molecular formula. If we divide that by the molar mass of the empirical formula, it will give us the ratio. Now, how do you know the molar mass of the empirical formula? Because you're told that is the empirical formula. So what is the if we add them up, it is, so carbon is 12, hydrogen is 1. So 26 divided by 12 plus 1, so 26 divided by 13, we get 2. So 2 tells us the ratio. So if the empirical formula is CH, we multiply each of them by 2. So C2H2, or ethene in other words, is the molecular formula. All right, let's have a go. So that was intro type question. Let's have a go at question 2. It's a bit trickier. So hydrazine is a highly reactive substance, I should say, when it is analyzed. Its percentage composition is determined by, so we've got 87.5% nitrogen, 2.5% hydrogen, and we're told it's molar mass. And we need to work out the molecular formula of hydrazine. Now, here we are not told the empirical formula. So what we need to do is we need to work out the empirical formula first, and then using the molar mass, we can work out the ratio, a bit like we did exactly the same steps as we did in question 1, and hence we can find out the molecular formula. So there's a few steps involved. So we're going to have to first of all find the empirical formula. So what have we got here? We draw up our table. We've got nitrogen and we've got hydrogen, and we don't have anything else, just those two. We're given it in percentages, so 87.5% and 12.5%. Just double check that adds to 100%. Yes, it does. So we can assume we have 100 grams of sample, so we can convert that to grams. Then we find the number of moles. Remember, N equals mass divided by molar mass. So we're going to find the number of moles. So 87.5 divided by the relative atomic mass of nitrogen. If we look at our periodic table, that's 14. Hydrogen is 1, so we're just dividing that by 1. And we get our number of moles. So 87.5 divided by 14, we get 6.25 mole. And here we have 12.5 mole. So these are our number of moles. There and there. And we take the smaller number, which is 6.25, and we divide each of those two things highlighted by 6.25. So 6.25 divided by 6.25, that will give us 1. 12.5 divided by 6.25 gives us 2. So our empirical formula is NH2. Now we need to find our molecular formula. So to find the molecular formula, the molar mass of the molecular formula divided by that of the empirical formula, and that will tell us the ratio. So the molecular formula, we are told that the molar mass is 32 grams per mole. It's 32. For the empirical formula, well, that's our empirical formula is here. And so we've got 1 nitrogen, 2 hydrogens. So nitrogen is 14. 2 hydrogens, so plus 1 plus 1. So that gives us 16. So 32 divided by 16, of course, is 2. So the ratio is 2. So that tells us that the molecular formula is, we just then take that 2 and we times it by, we've got 1 nitrogen there, times that by 2. 2 hydrogens, we times that by 2. So our molecular formula is N2H4. And that's it. And you can have a go at question 3.